Hello all, let me start our session with the simplification of standard sum of product form and standard product of sum simplification. So last class we learned about how to represent a K-map on 2 variable, 3 variable, 4 variable as well as 5 variable. Now, so need for K-map. So why we are using this K-map, sir? So in order to minimize your Boolean function which are in the form of standard SOP or in standard POS form. So it's a graphical method of simplification of your Boolean functions, which can minimize your function into minimum number of literals. And we are going to use a grid-like diagram, and we are going to use the method of minimization based on your adjacency. So upon minimizing your function will be in the form of simplification and reduces that simplification of your function can reduce the number of logical gates for implementing your function, and it minimizes the circuit complexity and improves your efficiency. So with this minimization we can achieve the simplest form of your Boolean expressions. So using your K-map method and using the adjacency in K-map, we are going to minimize your functions which are in 2 variable, 3 variable, 4 variable and 5 variable functions. For these 3 variable, 2 variable, 4 and 5 variable, your K-map is most preferable one. So 2 variable K-map can have 4 minterms or 4 maxterms, and it is represented with 4 number of cells or squares. So in each cell or in each square we are going to map your minterms or maxterms. Now this first cell corresponding to minterms mapping. So first cell is occupied with M0, second cell is occupied with M1, third cell is occupied with M2, and the last cell with the M3 in the same manner. So here we are going to map your SPOS form. First cell with M0, second cell with M1, third cell with M2, and fourth cell with M3. So possible max terms for the 2 variable function is 4 minterms and 4 max terms. So now minterm functional values are logic 1 and max term functional values are logical 0. So minterm functional values are logic 1 and max term functional values are logic 0. So those we can have to map onto your corresponding cell. For example, now if I give a function with a 2 variable f of ab is equal to sigma m of 1 comma 3. So now as I have given the minterm, hence onto the corresponding cells of your m1 place m1 and m3 place the 1. So this method of placing the functional values onto the corresponding cell is called mapping. So now if I wanted to map your function using your max terms, so then my given function must be in the form of your standard POS. So in standard POS, we are going to represent product of sum terms or product of your max term. For example, now I have given a function which is pi m of 0 to. So sum term functional values are zeros. So in the corresponding cells of 0 and the corresponding cell of m2, place your functional value is 0, which defines the mapping. Placing the functional values onto the corresponding cells defines your mapping of the given function. The same manner here, 3 variable function is represented with 8 minterms or max terms. Now, as here in order to obtain that 8 number of cells on a square, so we divided that big square into 2 rows with 4 columns, and we use the indexing here for the first row index with 0, second row index with 1. So here we represented in the below axis the most significant variables of your function, and in the above axis we represent your least significant variable. And here the columns are indexed with a sequence of gray code, not a binary. So in binary you doesn't have your positional difference is 1 in your successive code word. Only in gray code the successive code word will differ by 1 bit position. Hence we are going to use the gray code sequence as the index of your rows as well as your columns. The same manner for your 3 variable max terms also we represented the same gray code sequence. First gray code one is 0 0, second one is 0 1, and third one is 1 1, and the fourth one is 1 0. Row index are 0 1. So here we will map your first cell occupied by M0, second cell is M1. So like this, so total number of cells we can have here, total it is 8. So M4 and here M5, then M7. So last one will become the M6. The same manner, maximum M0, here maximum M1 and maximum M3, then M2. Here M4 we can map. So next M5, M7 along with M8, M6. So total number of maxterms available on your 3 variable is 8. So these all the maxterms are mapped onto the corresponding cells. Then we will go for the adjacency method. A 4 variable map should have your 16 number of cells. So hence we are going to use total 4 rows with 4 columns, which could have your total number of cells are 16, started with small m0 to ended with your small m15. In the same manner, so maxterm, so first test cell is started with the maxterm m0 and the last cell will end with m15. So these all the maxterms are mapped, and then we will go for your minimization using adjacency method. Now as here we were discussing about the adjacency. Adjacency is nothing but the cell difference. So if you have only one bit difference between the two cells, then we could say that those two cells are adjacent. Now here when I am observing, so A bar, B bar, C bar, D bar, whereas here A bar, B bar, C bar, D. So it is differed by only one bit position difference, hence 0 is adjacent to 1. The same manner here. So now always we need to remember in your 4 variable K maps, so these uppermost cells are adjacent to the lowermost cells, and here the left corner cells are adjacent to the right corner cells. So now, so this we have to remember for grouping. So as here like a paper we will have, so if we fold the edges, so the topmost one is adjacent to the lowermost, and your sides, right side edges and left side edges are adjacent. So in the same manner in a K map, so your uppermost cells all are adjacent to the lowermost cells. Your rightmost cells are adjacent to the leftmost cell. So in the same manner in your max terms also. Next we will go for your 5 variable, so which is defined with a 4 variable K maps, as you have to use as a 2 layers. The topmost layer which will have A0, A equal to 0, and the bottommost layer is having A equal to 1, and we are going to represent the minterms, which are M0 is the first minterm and the last minterm will be represented with M31. So here based on the given function minterms, you have to map your function and use the adjacency technique, then minimize your function into minimum number of literals. So these are the mapping for POS function. So capital M0 is the first cell and M31 is the last cell here. So this also represented with a 5 variable function, which is represented using 4 variable, as the first layer is having A0, second layer is having A equal to 1. Now upon mapping your function, next method is adjacency. So this adjacency defines, so cell adjacency is defined with in between your two cells which are adjacent when they have only one bit positional difference. For example, now 0th cell, so with a 2 bit I can represent as 0 0. The first cell with a 2 bit I can represent as 0 1. So now here when I am observing the lower significant bit position, bits are differ and the most significant bits are equal, so both are 0 are same. So hence I could say that so 0 is adjacent to cell number 1. In the same manner, when 0 is adjacent to 1, so here your cell number 2, which is designated with the logical 0 and 1, is 1 0, and cell number 3 is designated with 1 1. So here also the lowermost significant bit is having a difference of 1 bit. Hence, so 2 is cell number 2 is adjacent to cell number 3. So your square 2 is adjacent to square 3. So next, the same manner in a column wise, your 0th cell is also adjacent to 2. So your first cell is also adjacent to 3. But whereas, so 0th cell is not at all adjacent to, so it is not at all adjacent to third cell, and first cell is not at all adjacent to the second cell. Since here 0th cell is 0, 0, third cell is 1, 1, and here 1, 0 is your second cell, and here your first cell is 0, 1. So 2-bit difference in between the cells may not be called as adjacent cells. So corner cells are not going to are not going to define as a adjacent cell. So based on this adjacent cell, we were going to group your squares. The same manner for a 3 variable, 0 is adjacent to 1, 1 is adjacent to 3, 3 is adjacent to 2, and here 0 is adjacent to 1, 1 is adjacent to 3, 3 is adjacent to 2, 4 is adjacent to 5, 7 is adjacent to 6, 5 is adjacent to 6, along with that 0 is adjacent to 2, 4 is adjacent to 6. As these two are on your right side, 0, 4 are adjacent. So 0, 4 cell are adjacent to 2, 6 cells. So because these are 2, 6 are in rightmost cells and your 0, 4 are in leftmost cell. So leftmost cells are adjacent, hence 0, 4 are adjacent to your 2, 6. The same manner for a 4 variable K-map. So the topmost layers, these topmost layers are adjacent with your bottommost layers, and your rightmost cells are also adjacent to the leftmost cell. So now by using this adjacency method, we are going to form a big square, and with that big square we are going to minimize your function. So big squares always start with your 2 power 0, which is only one cell adjacency, which is called as isolated minterm or max term. So minterm or max term. So 2 power 1, which is equal to 2. So 2 square adjacency is called a pair, and 2 square is called 4, so which is called as a quad. Next, 2 cube is 8, which is called as an octet. So 2 power 4 is equal to 16, so which is called as a double octet. By forming these all the groups of your each square adjacency, or we can form a big groups, so which could minimize your function. So now, so what are the do's and don'ts in your K-map method? So that we have to discuss. Here the minterms are arranged diagonally, so we can't pair diagonally. So these must be written as a isolated minterm. So your minimal expression for this case is equal to a bar b bar or of AB. So hence here this to be written as it is, because we cannot form a big square because those 1, 0 and 3 cells are not adjacent. So next, here we have another case with the 3 variable. As I have total minterms are 5 minterms, so I can have a possibility of your grouping is 1, 2, 4, 8, 16, but the first picture will give you the 3 minterm combination and along with 2 minterm combination. So it cannot have your 3 minterms combination, it only have your 4 minterm combination. So hence we have used here, since your 0 is adjacent to 1, 1 is adjacent to 3, 3 is adjacent to 2, 2 is also adjacent with your 0, hence we can form a quad or a group of 4 square adjacency which can form a group. And here in order to cover this uncovered minterm, I am going to use the already covered minterm. So this is the correct way of your grouping your squares into big one. Okay, next we are going to have another example. So now earlier, so we have 0 and 3, now it is 1 and 2, which may not be paired. So since they are not adjacent. Next here another case we have it. So this is the correct way of representing. So as 1 is adjacent to 3, so we can form a pair. So 1 will be left here. So in order to cover this minterm M2, so I can use already covered minterm M3. So then we can have here a function which is equal to minimal expression is equal to, as here for this 2 minterm the common variable is b, and for this 2 minterm the common variable is a. So hence the minimal expression is br of a. Now the second way of here, a wrong way here, because you're grouping one max term with a one min term. So this is the wrong way of your grouping your method. So either you have to mark only the min terms or only the max term. So next, the correct way of representing here it is only it can possible to group with the min terms only. If it is not possible, that min term must be written as it is. Next, here we have a possibility of here grouping with the 4 square adjacency. So hence we used a grouping of 4 cells. So as 4 cells adjacency, so hence we form a quad, a row wise. So next only 2 minterms are left, and we are going to use here the already covered minterms. So with that, so we could have your minimal expression for these 4 minterms. The common variable is a bar, and these 4 minterms the common variable is equal to b. In column wise it is equal to b. Next here, this is the wrong way of representation of your grouping your function. So as you have a big group, so we should not prefer a small group. Here we could have a 4 square adjacency. So instead of using that 4 square adjacency, we should not prefer your small square adjacency, which is a pair. So if it's possible to form a big square, we always have to check for your big square adjacency, not a small square adjacency. Now in this example, so I've given, so total minterms are, total is 7 minterms. So as your corner cells are adjacent, so hence we can form with these 2 minterms and these 2 minterms a quad. And then so in order to cover these 2 minterms which is on your 1 and 3, so A is covered with quad, and to cover your the last one, so which will prefer only the big square, not your small square. So if your the remaining 3 are already covered, you can use your already covered minterm in order to cover your the uncovered minterm into a big square. So like this, so we're going to minimize your function in a correct way by forming into a big square. Next, 3 minterms grouping is not possible. So this is the wrong way of your adjacent minterms. And here we have a combination of minterms along with your max term. So we could not prefer this. So this is also a wrong way of your adjacency. And here only the minterms are covered. So with the 2 squares, so for 4 squares of 4 squares are there, so which can cover your all the minterms. So hence this is the right way, and this one is your wrong way of your given function. Next, so here also we have 1 1 1 1. So we should not prefer the lower squares. Instead of here we have to prefer the higher order squares, so which can form a 4 square adjacency, not with the 2 square adjacency. Next, so this is the wrong way of your adjacency, and this is the right way of forming into a big square. Next, so these minterms are arranged in the corners of your every corner of your K map, where you can't take this as a isolated minterms. So it is the incorrect way of your adjacency, as the cells on your rightmost cells are adjacent to the leftmost cells. So we can form 0 is adjacent with the 2, 0 is adjacent with 8, 8 is adjacent with the 12. So next, sorry, 8 is adjacent with 11, So 2 is adjacent with the 11, hence we can form a quad. 4 square adjacency we could form as here. Minterms are arranged in the corner. So using these do's and don'ts, so we could minimize your given function. And in the next class, we will start with our how to minimize your function using 2 variable and 3 variables.